Okay, that was a great talk by Jeremy. I'll try to convince you that MRI is better than CT. Why is MRI the best? Well, it's quick. It doesn't take any more time than CT. It shows tissue injury as opposed to the CT that just shows an abnormality of flow. And it's irreversible, the DWI lesion. So I think that's basically the summary. And I could leave it with that, but that would make it a short talk, so I thought I'd give a little bit of background. How do we know that MRI is best? Well, we have very good supportive animal data. Here is data from 1990. This is a cat who has had a left MCA stroke, and you see after 1 hour the diffusion lesion, after 5 hours and 12 hours, and then the cat was sacrificed, and on histology, the stroke lesion on diffusion weighted imaging corresponds nicely with the infarct on histology. So DWI can image early infarction in real time. We knew that back in 1990. That was worked by Mosley. And ADC restriction indicates energy failure as a hallmark of irreversible injury. Oh. So what about if the cat had a reversible lesion? What about if you have a thrombectomy and you restore flow? Well, soon after those early studies, studies were done in rats and other animals with a reversible ischemia model. So here there was 20 minutes of cerebral ischemia in rats. And in black, you see the ADC signal during ischemia. It quickly dropped. Then blood flow is restored and the diffusion signal normalizes. The ADC goes back to normal. But that doesn't last forever. At 24 hours, so at the very end of the graph, in black, the ADC has dropped again, and so the diffusion signal is present. So yes, you get transient reversal of your DWI signal, but in the end, it becomes positive again. So DWI seemed irreversible. Well, what about having even shorter times of ischemia? So here was a couple years later, another study in rats where after 10 minutes reperfusion there was only 10 minutes of ischemia, and with such a short duration, there was actually permanent reversal of the DWI signal. If they did 30 minutes of ischemia, there was no reversal of the DWI signal, as shown here in this graph. On the top, there's 10 minutes of ischemia, on the bottom, 30 minutes. So maybe it is not entirely true that the diffusion signal is always irreversible, but if that's, for that to be the case, the duration of ischemia has to be really, really short. So that's the animal data. We also have good clinical data. This was a study that we did early on in the 2000s, where we looked at the diffusion lesion after 1, 2, 3 days and compared that to the final infarct at 25 days, and there was a very good correspondence. Did the entire diffusion lesion infarct? Well, there is some variability in the ADC signal, and we did a follow-up study where we looked in the Diffuse-1 data, where we looked in patients who reperfused, and we looked at the entire area that was hypoperfused. We looked at the DWI signal and said, well, what part of the DWI lesion is going to go on to infarction with complete reperfusion and which part doesn't? And what we found out is that if you set the cutoff for an ADC less than 615, you get the best differentiation between permanently injured tissue versus tissue that can reverse. So there is some thresholding that's necessary even with the diffusion. Here's question about reversibility. Does it exist in humans? Here's a patient came in with a lesion, a core lesion of about 5 milliliters. Depending on how you threshold it, large Tmax lesion, went to the cath lab and was recanalized the day after. The perfusion scan looks normal. The diffusion has completely reversed. And what we found a bit surprising at that time, but now have seen many times, and you probably have as well, on day 3 when we did a follow-up study, that just like in the rats, the diffusion reversal is only temporary. and at the final follow-up at 3 days or 30 days, you'll see a lesion that corresponds to your initial DWI lesion. So the third one, so we have supportive animal data, supportive clinical data, and we don't have great alternatives. So we have CTP, but that's based on flow, not tissue injury. And so there's issues with that, because if there's been a change in your perfusion status, collaterals have kicked in, there's partial reperfusion, by definition the CTP will not pick up the core, and it's time dependent. If you have only had low perfusion for 10 minutes, half an hour, the thresholds are going to be different than if you're 3 hours, 4 hours out from your stroke. Also, the traditional criteria for the core was an absolute CBF less than 10 milliliters per 100 grams of brain tissue per minute. And with CTP, we don't get absolute CBF values. We get an estimate of that, we get relative CBF, we get relative CBV, we can look at other parameters, MTT or Tmax, but we don't really have that absolute CBF value to look for. So we try to look at how close can CTP get to the ischemic core as identified on diffusion-weighted imaging. And we created this benchmarking tool where we had the data set of diffusion imaging that were obtained in close proximity to the CTP in the same patients prior to treatment. And this is what we showed. If you use CBF and you threshold it at 38%, the difference between your diffusion volume and the CTP core is 0 milliliters, so it looks great. Right in the middle, you don't overestimate, you don't underestimate, you're right on. So CTP seems perfect, right? Well, not always. This is the scatter plot of each individual patient. So even though the average difference between the CTP core and the diffusion core is 0 milliliter, if you look at each individual patient, on average, there's a 60 milliliter difference between the two, and the spread is plus or minus 40 milliliters. So if I tell you you have a 30 milliliter core, it could be as little as 0 or as much as 70 milliliters, and there's even outliers. So CTP is accurate, but it's not very precise. And maybe the strongest argument pro MRI is that Jeremy and I have jointly taken transfer calls for many years now, and Jeremy has recommended MRI upon arrival at Stanford in, as I recall, 100% of the cases. Thanks.